Hi, friends, and welcome back to Curiosity Studios at the Pacific Science Center. My name is Michael, and I am so happy that you get to join us today and to explore all of the different things that we like to explore at the Pacific Science Center and really explore our curiosity. With me today is my friend Zita. She's on the chat. So if there's any questions or observations that you would like to make, please go ahead and share them on the chat. For example, I'm curious, how did you all hear about this event? Can you let us know how you heard about this event? And so we might be able to learn more and share this experience with more people. A few rules before we start really starting to explore our science today. First, it's really important that you have an adult friend in the room. They could help message your observations or your questions to us. And they could definitely help you share in your exploration of your curiosity. I really like it when people ask me questions. So be ready to share a lot of your questions and a lot of your observations with me. I am happy to really shout that out all to you. And then finally, I'm just going to let you all know that this is about a 20-minute show. And I'm looking around and I'm noticing, you know what, friends? Things are really, really dark in the studio right now. And that could only mean one thing. Today, we are going to explore a lot about light. Lights could brighten up the studio, lights that actually shine on our world, the light that comes from the sun and all of the different things it does with our senses so that we can see and feel warm. We're going to explore a lot about light. So friends, if you are excited to be sharing about lights, let us know, give us a big applause and, give Zita a little hello. That would be great. Now, I was thinking about lights and I am reminded of a fantastic story about my friend Sonia. So we're going to start our exploration with what Sonia was doing with her observations about lights. And this quick little story. So everyone gather around your computer, gather around your screen, and let's explore Sonia and the light beam. All right, friends. Sonia loved to read books. She loved to read her science books before bedtime. Some of her books were about insects. Others were about electricity. Some even had a book about sunflowers. One night, Sonia read her newest book, which was all about light. Sonia read that light travels very fast in a straight line. She also read about all the many things that make light. One of the biggest things that make light, the book said, was the sun. But looking at this page, I could see lots of different things that makes light. Let's all observe and see if there are different things that are also making lights besides the sun. Go ahead and share that with your adult friend and explore. Let's see here. I see Sonia, she's camping in her tent. It looks like she has a flashlight. That is amazing. That is awesome. And then next to her is a car with a headlight. Does anyone see what Sonia's adult friend is doing? That's not light made out of electricity. That's light made out of fire. It looks like he's cooking on the barbecue. And Sonia's other friend is capturing lightning bugs. They glow, and they're animals that make their own lights. Any other observations about lights you might see on this page? Friends, you're right. There are more lights coming from the sky, not just from the sun. We have lights from the stars and the moon. The sun is a big light maker. The sun is the closest star to the Earth, 93 million miles away. It sits at the center of our solar system. That seems very far away, thought Sonia. The sun might be very bright to light up our days on Earth. Sonia read that the sun is a gigantic ball of gas, more than 1 million times bigger than the Earth. As the gas burns, light beams shoot out from it in all directions. As Sonia read on, she grew more and more tired. As she drifted off to sleep, something strange happened. Sonia dreamt she was a beam of light shooting out of the sun. She was moving through space very, very fast, 186,000 miles per second. And there were many, many other light beams, all heading in different directions. Sonia looked up to see where she was going. She was headed towards the moon. As Sonia got closer and closer, the moon seemed to get bigger and bigger. She could not slow down. Will I crash? She wondered. What do you think would happen when a light beam hits the moon? Does it crash on the moon, or does something else happen to that light beam? When the moon seemed just moments away, Sonia shut her eyes, but nothing happened. After a few seconds, she opened them and was surprised to see she was heading away from the moon, and it seemed to be getting smaller and smaller behind her. She had bounced right off the moon. The moon reflected me, she realized, and she was happy about that. That's a really interesting idea. The idea that light can bounce or reflect. That's an interesting idea. Let's hold on to that idea so that we could explore a little bit more about light and what it could do. Sonia looked up again to see that now she was heading towards a big blue ball. Oh my, she said to herself, that must be the planet's. Well, friends, which planet is a big blue ball and has some green on it? I see some white clouds. It must be really, really close to the moon. What planet is that? Oh, I hear you shouting. It is the Earth. Oh, she is headed right back to the Earth. Sonia's light beam shot towards the Earth. In just a few seconds, she found herself in the middle of an early morning rainstorm. There was a rainbow right in front of her. Do you all see the rainbow? What colors of that rainbow do you see? What is your favorite color of a rainbow? I'm hearing some orange. Oh, one friend said green. I really like green too. That's a great color of the rainbow. As her light beam moved through the raindrop, she noticed something strange. Sonia looked like a rainbow. The raindrop had refracted her light beam and split her into different colors. Oh, what great fun! All right, we definitely see Sonia. She's green and red and yellow. As she traveled out of the rainstorm, Sonia saw that her light beam was headed at a beautiful stained glass window. It looks to be a part of the art museum, like the stained glass windows you might see at the SAM. What do you think might happen to her light beam as she goes through that stained glass window? What happens to that kind of light beam? Well, let's find out. Her light beam passed through the stained glass window that was a picture of a flower. As her light beam filtered through a leaf, she turned green. And as other light beams filtered through the windows, they turned other colors. I look like a frog, she squealed. All right, that is amazing. So light could change different colors if it passed through different filters. That's really interesting, friends. Let's explore more about that soon. Just then, Sonia woke up to find the sun shining hotly on her face as she lay in bed. She got up and ran to her brother. I just had the best dream, she told him as she woke him up too. I learned so much from my book that I dreamt I was a light beam from the sun. What are some things that you learned about light beams when Sonia was traveling from the sun all the way back to her bedroom? Do you remember what happened to her when she was approaching the moon? Do you remember what happened when she passed through that raindrop? And then what happened to that light beam Sonia was acting like when she passed through that stained glass window? And I want to give a big shout out to Hudson and Amina. And thank you so much for joining Sonia in the light beam. Sonia said, I really liked streaming. I was a beam of light. Maybe I'll have another science dream tonight. Well, friends, I think Sonia has given us a lot of different thoughts about what happens to light and what it can do and not do as it goes through space or goes through the room around us. And I think we really need to explore all of those different topics just to see if we can understand all of the different features. And just maybe some of our friends could see their light turn into some of their favorite colors, like orange and indigo and red. I love how everyone is sharing their favorite colors with each other on that chat feature. Keep doing that. Now, friends, the first thing I wanted to explore was the idea that happened to Sonia when she was approaching the moon. She was traveling as a light beam all the way from the sun. And as she hit the moon, she bounced. She reflected off of the moon. That's a really big word. So let's say reflected together on the count of 3. Are you ready? 1, 2, 3. Reflected. Nice. Reflected, all that really means is it bounces. And light can definitely bounce. The biggest way that light bounces is with a mirror. Go ahead and explore after this program some mirrors that you might have home. There might be some mirrors that reflect or allow light to bounce, or there are other things that will reflect light or make the light bounce. My favorite is a spoon. I love exploring the spoon because I can see my face inside this. And my face looks really weird as the light bounces off the spoon. Like when I look at the spoon this way, friends, I'm upside down. Oh, so friends, if I turn the spoon this way, how would I look this? Oh, wow, that is really weird. Well, if you want to experience that, right after this program with your adult friend, grab a spoon and look at yourself in the spoon and see how that light bounces. One of the really cool, curious things is, you know what? With all Sonia's adventure, I can't really even see light. It's really kind of interesting because, like, for example, I have this flashlight and I can see where the light's coming from. And then I can see how it's shining on my face. Or I could see how it bounces off of my picture, a globe of the moon. But I can't really see the light travel from my flashlight to my moon. For example, can you see the light in between my flashlights and the moon? Is it really shining? Well, to help me figure that out, I've got a special type of light. I got a laser pointer. There it is. And right now, give me a thumbs up if you think this is turned on or turned off. Okay, look at that, it was turned on. And that means I couldn't see my laser pointer. So what I really need to do is give the light something to bounce off. And for that, I just have some fog in a can. And I could actually just go ahead and spray this in the air, and the light beam reveals itself as it bounces off all that dust. Oh, I turned it off. Now it's back on. And to see it, I need that light to bounce through. All right, that was a great experiment. There's other things that can make light bounce, like glass. We use glass to actually send light. And so if I just point it, it doesn't really do anything that special. But if I put it through the glass, oh, friends, what just happened? That light is bouncing in my glass and it's making the entire thing glow. Let's get a little bit closer and see if we could see that light bouncing. Do you see how light wants to travel in a straight line, but then it bounces up and down in my glass tube? That is amazing. All right. We can even do it a little bit simpler with this glass tube. Oh, just look at that bouncing. It is so bright. I'm going to move this away. It's so bright, but we could see it make the entire glass tube glow as it bounces inside that glass tube. That's awesome, friends. But what else was light doing in Sonia's book when she was exploring? Let's see. She went to the moon. Where else did she go? Maybe Hudson and Amina could help us out. Where does it actually go? Oh, what was that? Oh, that's right. She turned herself into a rainbow. Sonia, when the lights passed through this raindrop, well, it looks like she was going straight, and then the lights from the rainbow, or the water from the rainbow, made her bend or refract and split her up. So that's a big word. That's a really big word. So let's say that together. We're going to say refract together on the count of 3. 1, 2, 3. Refract. Refract means to bend or to split up light. And we could do that with water. That's, after all, what a raindrop is made out of. And so you could see me here, and this is just a little tube of water, which really kind of cool. Oh, friends, what's happening in my face when you look through the water? This is so weird. I'm turning upside down. Oh, friends, this is really weird. The light is being bent and split up in my water, and it's helping me turn around. There's an experiment that you could do at home right after you get a spoon. All you need is a glass of water and a pencil and some objects that you could put inside the water and see what happens to the shape of your pencil when you dip it into the water. That's something you're going to have to share with us and your adult friends from your own experiments. All you need is a glass of water and a pencil. But my favorite thing about the bending is that Sonia made a rainbow. She really split apart. She really fracted. Oh, and that is one of these. This is filled with tiny little prisms, just like a raindrop. And that takes this white light that we normally see. And friends, look at that. We have shiny, shiny rainbows, meaning all of the white light is made up of all of those different colors. Go ahead and give me a big shout out if you see your favorite color, like that orange or indigo or red, as we look and explore as that light breaks up in my little film here. That is fun. I love having a rainbow on my face. This is great. We could also use lenses to help us bend our lights. Different shapes of lenses. And that can really help a lot of people. For example, I love to wear my glasses. These are lenses that help me see. And they help to reflect on the screen monitor. It bends lights too. And remember that big word again. Let's try that again on the count of 3. We'll see refract. 1, 2, 3. Refract. And that means it's splitting up and bending lights. Some lenses are shapes really weird, so they make things a lot smaller. Do you see my face inside? Oh, look, friends, I'm really, really, really tiny. Inside this lens, I am really, really small. But without the lens, I'm really, really big. And then there are other lenses that we have that could take the small and make them really big based on how it bends or moves the light. So let's observe this. Do you see my big giant mouth now? I've got a big mouth and tiny eyes. I've got a big mouth and tiny eyes. I've got a big mouth and tiny eyes. That's all because of the way light bends and bounces and refracts and splits. Now, friends, for the last one, what was Sonia doing again? Oh, yeah, she was traveling to that art museum and she went through that stained glass window. And that's when she turned into a green frog. Like, no. She just turned green and looked like a frog. That's right. Thanks for correcting me. That was a good observation. All right. So how does that happen? Well, for that, friends, that's experiments that you're going to have to do at home with your other friends and sharing your curiosity. You could use different filters and different types of lights, things that you could see through that might be different colors, and experiment with how they might actually change the color of different objects. And that's an experiment that you're going to have to do at home with your adult friends or with your other friends. To learn more about how to do those experiments, have your adult friend go to pacificsciencecenter.org. Look for the Curiosity at Home page. There are lots of videos that you could watch about different colors and how they blend. And there are some activities that you could use, like our lights activity with the water, that you could download and actually try out at your own kitchen with an adult friend or another friend. The important thing is that you stay curious. And friends, I want to thank you so much for joining us. I am so happy we could do this activity every week this summer to help support our programs and to provide more educational programs for this fall when everybody's staying home, even though they're going to school. Please help us fill out a survey so that we can learn more about how to really effectively bring these early childhood programs to schools across the state. Also, we are offering these programs for free right now this summer, but help us and support our efforts by going to pacsci.org and look for our support page. Every little donation counts, whether it's $5 or $5,000 or $500,000. It all supports programs like these and the activities you could download at Curiosity at Home. And of course, you could support us by joining us. Become a member. Even though the center is closed, Curiosity never closes. And there's still a lot of activities and explorations that we are sharing with our community. So become a member and join us in sharing the curiosity that we have in the Pacific Science region. Well, with that in mind, I want to say hi again to Hudson and Amina. Thank you so much for joining me and sharing your favorite colors with the entire group. I am so happy that you were able to be curious today as we explored and joined Sonia as she explored the different light beams and what happens to lights. And I really hope that you continue your exploration with the different experiments that you could do in your own kitchen. So thank you so much for joining me again. I am so thrilled to have been joining you. And remember, always stay curious. All right. Thank you, everyone. Bye.